we have the molybdenum compound molybdenum related actual analog material, and sulfur, for example, for sulfur usually we will take the thiourea. So we have to combine these two materials. In this one, by combining, so here a nucleation starts. So in this one, while the nucleation starts, as soon as the nucleation is started, the growth of the material took place. So when the growth of the material took place, there is a possibility to combine the two nucleons together, so that the agglomeration took place. So to avoid agglomeration, what we will use is, we will use the capping agents. So what I have ethylene, so here polyvinyl propylene citrate, gluconine. So all these things are called the capping agents. So these capping agents hinders the growth of a particle. As soon as it does, it limits the growth of a particle. How it limits means, because of the steric effect, the forces, they hinders the growth. So like that, we can grow the size of the nano material in the required manner by using the capping agents. So the capping agents are very important by growing the nano materials in the required shapes and shape. Okay, so these capping agents playing very important role. So we can talk. So when you these capping agents, what are the capping agents that are to be used? So what we will do is, we will prepare the material by using different capping agents. We can see that also. So so this is actually the, what is the procedure? For example, to grow the cadmium sulfide nanoparticles, so we will take the cadmium acetate, and in place of the sodium sulfide, we will take these two things, and we will dissolve those two materials in the deionized water. Then we will combine the solution. Then we will add the capping agents. Here they took the three capping agents: polyethylene glycol and ETTA, polyvinyl propylene. So like this, they prepared the same cadmium sulfide by using the three capping agents. So this is actually the process that is to be followed in actually in getting the particular solution. So that means we have to mix that one, and we have to heat the material in the magnetic stirrer, and finally we have this one. We will filtration, and finally we will get the yellow color cadmium sulfide powder. So like that, you will get the actual thing. So here, this is a pure cadmium sulfide without any capping agent. So next one is PEC cap and EDTA cap and PVP cap. So when you observe these four morphological studies of the cadmium sulfate, so when without any capping agent, all the material particles are getting agglomerated. So as soon as when you add PEC, so the agglomeration is decreased. So that means by using the PEG, so the particle size is very limited. So when you observe the EDTA and the PVP, in that one also the particle size is very large. So depending upon the actual requirement, what you can do is, we can take the capping agent. So for which capping agent we are getting the required size of the particle, that is also more important. That means we have to go for trial and error procedure, which capping agent is works on the material and which is giving us a small size of a particle. So like that we have to, so all this research is a trial and error procedure. We don't know what material works, how we will get that work. So every research is nothing but a trial and error. We have to do the research with all materials, then we have to find out which is a good depending upon our requirement. Based on our requirement, we have to go on working on this one. Finally, we will get the results. So like this, we have, this is the cadmium sulfate is prepared with a copper sulfate. This is for actually we did research on the magnetic semiconductor because of the magnetic effect, because the radiomagnetic semiconductors are used in the spintronic devices. So that we carried out research on the dilute magnetic semiconductor. So in this one, copper sulfate is doped with a ferrous in that one. So this is actually the, so here there is a particles, but in this one it is not actually the projector is not good, so that we are not able to see the resolution of the projector is not in a position to explain it what the particles are present in that one. We can see all those are the same figure, but that is not the correct. So in this one we have different sizes of the particles are also there. This one. So here, this is actually the hysteresis behavior of the materials that were prepared. So in this one, sulfate with different doping concentrations of the ferrous. So we take 0.01, 0.03 and 0.05 and 0.07 like that. Those are the doping concentrations of the ferrous. So in this one, we have the, so when you observe all these things, so we have a good hysteresis loop for the 0.05% of the ferrous. So like that, what we will do is, we will prepare the material, take the hose, and we will dope the hose with different concentrations of the different elements. So we will see which material is giving us a good hysteresis loop, and what are the, so actually when you take the cadmium sulfate, it is a diamagnetic character. So by adding the cadmium sulfate in terms of the ferrous, we are getting the ferromagnetic behavior. So like this, what we will do is, we will modify the property of a material by using the doping agents depending upon the actual requirement of the device. Okay, like this we can prepare the, so this is actually the research. So this research is useful to develop the technology. So this is another method. This is the hydrothermal. This is also called the salvothermal method. In this one, you require the autoclave. So in that one, we don't require any, in the case of the chemical precipitation, we don't require any autoclave and all. We need only the burette, magnetic stirrer and furnace. These three things are enough to prepare nanoparticles by using the chemical precipitation. But hydrothermal is somewhat expensive. In this one, we have to buy a autoclave that is cost around 12,000 like that. So in this one, what we do is, we will prepare the material and we will pour the solution onto this autoclave, that is called the autoclave. So we will pour the solution onto this autoclave and keep that one in the furnace up to temperature of 200 degrees, 300 degrees like that. So like this is actually the experimental procedure what we have followed to get the actual nanostructures by using the hydrothermal method. So these are the actual, what are the nanostructures we obtain as per the hydrothermal method. So when you take the chemical co-precipitation method, we will get only the particles. Particles have dimensions 30 nanometers, 50 nanometers, 60 nanometers like that. We will get only the nano particles by using the chemical process. So it is not possible to get variety of nanostructures by using the chemical process. We can get variety of nanostructures. We can get the wires, rods, bells, flowers like that. Different types of the nanostructures by using the hydrothermal method. So by controlling the temperature, what we can do is, we can grow variety also. We have done a lot of research on hydrothermal method also. We prepared any number of materials in our lab. So hydrothermal means we can get variety of nanostructures by using the hydrothermal method. That is actually the beauty of the hydrothermal method. You can grow any number of structures. So this is another method is a salt gel method. So this is mostly for metal oxides in the salt gel method. This is also the same as that of the chemical co-precipitation method. But in this one, we will get the gel. So that gel, from that gel, you will get the material. So this is somewhat different compared with that of the chemical co-precipitation. But the experimental procedure what we followed for the salt gel method is same as that of the actual chemical precipitation method. In this one, no need to have the autoclave and all. Same beaker, same furnace. But this is mostly for the metal oxide. When you go for the chemical precipitation, so we can do it for metal oxide and for all materials. So that is a chemical process. But in the case of the salt gel, it is mostly for the metal oxides. In this one also, we can get variety of the. So this is actually the bismuth oxyhalide we prepared by using the bismuth oxyhalide we prepared by using the hydrothermal. So this is the salt gel process. How the salt gel process took place. In this one, we have the solution after hydrolysis. So we can, in this one also, when you are depending upon your requirement, so you can prepare the fibers, you can prepare the films, and we can prepare the powder form also. So like that, we can prepare different variety of the materials by using the salt gel method. This is also a very important method. So in this one, these are the morphological actual structures what you have drawn by using the particular. So in this one, so actually this host is a bismuth ferrous oxide. This bismuth ferrous oxide is having a variety of properties. So it is a multiferroic material. That means what is a multiferroic material means? So when you take the magnetic material, so as soon as you apply the magnetic field, you will get the magnetization behavior. So when you take the actual ferroelectrics, when you apply the electric field, you will get the polarization behavior. So what is the actual ferrous oxide means? In this one, by using the magnetic field, you can get the polarization. So by using the electric field, so we can get the magnetization. That is actually the multiferroic material. So that this bismuth ferrous oxide is a multiferroic material. So in this one, what is the advantage of this? When you form the material in a correct manner with the correct stoichiometry, so what is the advantage of this material is, so for switching devices, these materials are very important. So when you want to use the material for the switching purpose, by using the electric field, you can control the magnetic effect. By using the magnetic field, you can control the electric effect. Like that, in the case of the switching devices, what we can do is we can use the bismuth ferrous oxide materials. So we have done lot of research on this material also in our lab. So this is also one important material what we have worked. So the magnetic properties of the materials are like this. So we will get the same type of behavior by using the electric field also, polarization also in the same material. So when you take the magnetic material, you will get this property. We can have the polarization behavior also like this in this material. So that this material is termed as a multiferroic material. That is also one important material what we have studied in our lab. So another important technique what we have designed